I hadn't started talking yet. CG, can you hear me now? I hate every bit of this, just so you guys know.
This is pretty bad.
I
Oh, wait,
think
CG?
that feeling's mutual.
So as far as mics, I think the thing that is most convenient to do, like right now with a group this size, I don't think it's going to be too bad. But also it's the morning, so it's quieter everywhere. But if it starts to get just too noisy with everybody's like background noises, you can just mute and unmute yourself as you need to.
Cool.
That's my family. Sounds good.
Can you all see each other, or do you just see my screen?
I can see other people.
I can see other
Yeah.
people.
Cool, that's what I thought too. So if you feel like you're looking a ratchet mess, which none of you are, of course, but if you ever feel that way, you can turn off your own video and just have your audio going if you want to. So just so you guys know, because I would be that person. As you can see, I have my name up there. Like, not that my hair looks really that different than what it normally looks like. So, okay, so I'm gonna start with the circle packet. I posted it on Google Classroom if you didn't pick yours up, but then if you guys have any questions, I'm happy to go through any of them, but otherwise I'll just hit the ones that I think are most important. We can just go page by page through first.
Yeah.
So on page 1, does anyone have any questions?
Ash, did you shower? Okay. Take a shower.
Does everyone know how to
Laundry
convert
room,
from
let's go
radians
away.
to degrees? We all okay there?
Yeah.
All right. Then page 2, does anybody have any questions?
Bathroom 2.
Oh, look,
I
you're
have
doing the
a
party.
question for the first.
You do?
Yeah. Well, I mean, I don't know if I have a question. I just don't remember how to do it. Like 6 and 7, because I haven't done this yet or looked through it, but that just looks like it might take more thought.
Sure. So 6 and 7, really, you just need to know what the axes are. So for degrees and radians, this is 0 or 360 degrees or 0 and 2 pi. And then what would the top of the y-axis be? What would the y-axis be? 90 degrees or pi over 2. And
that would the -1. Right.
And then 3 pi over 2 or 270. And really the main reason why you need to know this is just if you start at an angle, how much is 180 degrees is like a half turn basically. So if my angle is here, then 180 degrees plus the angle would be here. Does that make sense?
Oh yeah, so you use the angle. Okay.
And then if it started, there's one where it says 90 degrees minus the angle. So I would just start at 90 and then move backwards if it's minus. So really the hardest part of that one is just knowing where to start the angle. If that makes sense.
Okay.
Yeah. Okay, anybody else? Or any more on that? Okay, then page 2. Two and 3 is just whether or not you have your unit circle memorized. So if you don't have it memorized, I suggest re-memorizing that. Question 4 is just about knowing the quadrants. So remember that it's cosine, comma sine. In the first quadrant, it's positive, comma positive, negative, comma positive, negative, comma negative. Ooh. And the last quadrant is positive, comma negative. So for example, for number 4a, it says 4 pi over 5, which would be in this quadrant. And since we're talking about cosine, it would be the same number, but the number would be negative. Makes sense? Cool. Anything else on that page for anyone? Keep in mind, a lot of this stuff a lot of it will be no calculator if it has anything to do with what's already on the unit circle.
So how much of this is going to be on the exam?
It really varies from test to test. Anything on the syllabus could be on the test. I would predict that the likelihood of this being on the test, like the harder part of this would be the non-calculator section for this particular unit. Like they might put a question or two in your calculator, but if it's in your calculator, then you just type it in. It's just knowing what to type in. But for the non-calculator, it's just being able to convert the unit circle and knowing things about the unit circle. Like numbers 8 and 9 ask you to graph without a graphing calculator. Which the way you do that is just by knowing your unit circle. So if you don't remember what sine of x looks like, it says it wants us to graph from 0 to 180, which I would say 0, 90, and 180 are the ones that I can easily graph off the top of my head. So for sine, what's the sine of 0?
Is it 1? I don't really know.
No. Sine would be 0.
Oh, cool.
So it passes through the origin, which if you want to memorize that, that's great. But if you know your unit circle, so the coordinate on the unit circle would be here. It's 1, 0. And since it's cosine, sine, the sine would be 0. Make sense? Okay, so then we would start at 0, and then at 90 degrees, it's 1, and at 180 degrees, it's 0 again. So if we wanted to sketch it, it would just look like this. Yep, that's it. Any questions on just sketching other than memorizing what the things are? Okay. Page 3.
How would you do number 6 on page 3?
So this one is converting to sine and cosine. So looking at 6a, what's the identity for tangent? Like how do we write it in terms of sine and cosine?
Like
Sine over cosine?
Yep. Okay. So for 6a, we would have sine of negative theta divided by cosine of negative theta. Sorry, my stylus is garbage, actual garbage. Cosine of negative theta. Okay, so the important part here is to recognize that if you take the angle and make it negative, so let me go back real quick. If you were to take the angle, let's do 45 degrees, which is square root 2, then the negative of that angle would be here.
Can someone tell me what the question looks like? I don't know if mine are mixed up or something, but I have no idea where we are.
Okay, so we're on the, so if you started on the front page, hopefully it says circle packet on it, maybe. I don't remember if I labeled them before I made
90
copies.
minutes calculator and one with all these sectors.
One says, number 1 on the front page of the packet says draw a unit circle for each part.
It's one that we got on Google Classroom. It looks like this.
Yeah, I
it's
think we picked it up in the classroom.
Oh, okay.
I had to print mine out.
Okay, so it's also on Google Classroom. I thought I had it there, maybe I didn't. But so number 6, the red line is what the negative angle would look like. So cosine would be positive. So it would just be the same number, right? But then the sine would be negative. So in this one, we can rewrite this. Sine of negative theta would become the negative sine of theta. And then cosine of negative theta is just the same thing as cosine theta.
Are we on number 6?
Yes.
Yeah.
Okay.
The one that says on the same set of axes, sketch the graph.
No. Page 3 says,
Given that cosine 40 degrees equals 0.766, find the value of.
Oh, I
I'm on
thought we were
page
on
2.
use the properties of sine and
yeah,
cosine.
that's where I am. That's where I am.
Oh, that's where you are? I don't know. Okay.
So you're on 6,
Yeah.
page 2.
Oh, am I still on page 2?
Yep.
I'm an idiot. Okay, cool.
Okay. So on 6, page 2, so it uses cosine of 40, which you can take where that would be on the unit circle and figure, so, okay, I'm so sorry, that made no sense. A full circle is 360 degrees, right? So cosine of 400 minus 360 degrees is cosine of 40. So it's the same number because you started at 40 and then you added 360 degrees. So if this is 40 degrees, if I add 360, that means I go all the way around the circle back to 40 because 40 plus 360 equals 400. So that means that the answer to 6A is just 0.766. It's just the same number. Does that make sense?
Yeah.
Okay, so looking at 6B, how would we relate that number in terms of 360 degrees, which we know, and 40 degrees, which we know? So that one would be 320 plus 40 equals 360, right?
Would it just be 0? Or would it?
So what I would do is the cosine of 360, which is right here, the cosine there is 1. So I would take the cosine, the formula that we're basically using is the cosine of 320 plus the cosine of 40, which we know they told us in the problem is 0.766, is equal to the cosine of 360, which the cosine at that red dot, according to the unit circle, is 1. So then you just do 1 minus 0.766, and you get 0.24234. Math is hard. So they're just asking us to solve for this right here. So this is like our x variable, and then it's just algebra. Okay, so on that page that Alicia's on, any questions there?
I don't think so.
Okay, so on the next page, I'm going to keep going with the one that I started just because I think it's one that y'all should be able to think through. So where I left off was negative sine of theta divided by cosine of theta, which y'all told me that sine divided by cosine is tangent. So this is just negative tangent of theta. Does anybody want to raise their hand if they're surprised that none of the boys are here?
No.
Oh, nobody? Nobody? Oh, me.
Fashion said he was going to, but
That's
Well, if
fair.
they have a day off, they're not going to do anything. So
Yeah, I mean, I wasn't necessarily expecting it to happen. I thought it was funny. Julia is at a hair appointment.
Yeah.
So I'm like, all right, sounds good.
Me tomorrow.
Again, I don't care. Like, it actually is a day off for y'all. I just wanted, if y'all wanted it, like, I can't spend more time on it. That was my point.
I don't remember any math from
Yeah, I really needed to review this.
any calculus. That's the only thing I know. So figured this would be
yeah,
good.
I
Okay,
think
so
I
this is a
just-
section that we want more practice on.
And vectors.
Okay,
Yeah.
that's the next lesson. So
cool.
So Thursday's class, we're gonna do a mock of like just old exam questions, which these are made by the IB, so they're modeled after IB questions. So y'all are welcome to go through this packet. I can also put up Delta Math for this stuff, in case anybody wants it. Okay, I'm here. I'm seeing some heads nodding. That's only if you want it. The only reason why I like Delta Math more is because it gives you the tutorials and the answers right away.
That's why I like that.
Yeah, I do have the answers in the textbook, but they don't give you any steps. Like, it's not really that helpful. And also, since I pieced together the textbook, it'll just be kind of disorganized. Don't tell Mr. Jewett that I'm illegally copying and downloading the textbook.
Didn't Dr. Rounds do that?
Probably. We all do stuff we're not supposed to. Okay. So anything else on that one page, like the next page, the one that I just did one on, starts with number 11, ends with number 10.
Can you go over? I don't know, maybe one from like 8, 9, or 10, like that kind of section. They all seem similar, but
Okay, for that one, since you're not being asked to do that without a calculator, which
okay.
could do this with without a calculator, but I don't think IB would necessarily ask you to.
Okay. If we can use a calculator, then that's fine.
If you weren't allowed to use the calculator, I would just rearrange the formula and you would get negative sine of x is equal to 2 tangent of x. And then just try to find the ones where they're equal, which is less than pleasant. So I don't think they would ask you to do that without a calculator.
Okay. So is 5 through 10 on that page? You can use a calculator?
Yes.
Okay, cool.
If there's no questions, I'm going to move to the next page.
What does it start with? Because I printed it, but I think there are a lot of
The next page starts with number 1 with a no calculator symbol. It says sketch the following graphs indicating any axis intercepts.
Oh, there we are.
Ends with number 4, and that number 4 is like has a weird box around it. Good.
Thank you.
Okay. Oh, he came and then he left.
I know. I was like, wow.
Oh, I missed it.
That's so fun. Okay, so number 1, any questions there or on this page at all?
I forgot which one is amplitude and which one is period. Like I know the number outside is one of them, and then you do like the other number over 2 pi or something.
Okay.
That's all I remember.
Yes-ish. Okay, so your amplitude is the A, and so normally your formula is A cosine bx plus c plus d.
Okay.
So your amplitude is your A, which on the graph, this is your amplitude. And then your B stands for your period. And the period is the amount of time for you to make one full oscillation. So from here to here would be a period. So you can do where it crosses the midline, or from a maximum to a maximum, that distance is the same. And the formula for a period is 2 pi divided by b.
Cool.
Which that one's not on your formula sheet.
Can you go over one for number 2? Any of them in number 2?
Yes. Oh, sketching. Okay.
Mm-hmm.
So sketching without a graphing calculator. So you have to know where cosine would, knowing what the parent functions look like is really helpful. So normally cosine hits at 1 over the origin. And has a normal periodic looking function. And then it comes back to the top again at 2 pi. And so one way to think of 2a, you could rewrite that equation if f of x is cosine. I hate this stylus. Sorry, then this is technically f of x minus pi over 3, which when you have a minus pi over 3 in the parentheses, what kind of shift is that?
Isn't it to the left?
No, but it is a horizontal shift.
So shift in the period.
Yeah, this one is to the right instead. And the reason I know is normally we think negative numbers, so that would normally be going to the left. But I taught my students last year that I always,
you're here.
yeah,
Yeah. You give me some difficulties when I'm here.
that these parentheses kind of look like they make an O, which stands for opposite day. And you do the opposite of whatever you think you should when it's in there. So instead of thinking negative pi over 3, it's more like positive pi over 3. So what we're doing is we're shifting this function pi over 3 to the right. So really, you just have to change where you're labeling it. So when it hits 1, so here would be, I would just label this pi over 3 instead. And then it normally crosses for the first time. Here, this would be, see this pi, this is pi over 2. So where it crosses the first time would be pi over 2 plus pi over 3, which is 5 pi over 6. So really it's just relabeling your axis to match the graph. So as long as you know what this parent function looks like, then you'll be okay. Maybe.
So since it's a sketch, it doesn't have to be exact, right? I can't remember what unit we were on, but with Dr. Rounds, we would do one line and then we do it with a different color and we would like look at it and subtract in our heads and then we would draw the new line or something.
It was like adding and subtracting cosine and sine functions or something.
Yeah, it would be a lot like this, and that's fine. Like some people, it makes more sense for them to draw over top. Like some people are like, oh, this is my new one, and then I'm gonna do this, and then like I can't even draw it exactly because the stylus sucks. You can do that. Personally, when I put more than one graph on the same thing, I start getting confused. But if that helps you, yes. As long as the shape is roughly correct, and I mean, again, my picture is even rougher than what I would normally do on the board, but I would just make sure that your maxes are hitting 1 and your minimums are hitting -1, and that your maxes over the x, where you want them to hit on the x axis, are correct. If that makes sense. Okay. Anything else on that page?
Number 4.
Okay, so for this one, it's just asking us to find P and Q. So P on the outside, that's where our amplitude normally goes. And our amplitude is the distance from the midline. So how far away from the midline are we?
5.
Yeah. So our amplitude, our P is 5. It's just really knowing where the parent function would put these things. And then our Q is in the formula. So our period is equal to 2 pi over Q. And can you guys tell what the period of this function is?
X.
Would it be pi?
It would be pi. How do you know, Madison?
Oh, that's a pi. I thought that was an X.
Well, no, that's fair.
Yeah.
I'm blind.
So the period for this one would be pi, which if you're looking at the graph, it has 2 full rotations within 2 pi. So really we've just cut it in half. We've like squished it together basically. And so pi is equal to 2 pi over Q. And then you get that Q is equal to 2.
Cool.
We all good?
Yep.
Okay. Let's see what else. Next page, any questions?
Is that the page that goes 5, 6, 7, 2?
Yes.
Okay.
How to do 5?
So similar concept, we're just looking for our amplitude and the shift. So the amplitude is the distance from the midline. So how high does it go?
2.
2. So our A in this case would be 2. And then to find the shift, normally the cosine function would cross the x-axis at 180 degrees, but instead now it's crossing it at 110. So I know it's been shifted by 70 and it's been shifted to the left, which means that the B would be -70.
Where does the sine graph hit the x-axis?
It hits it at 0 and it hits it at 0 and 0 and pi. So it shifted more. I'm sorry. Ignore me. So instead of being 180, normally the cosine function hits the x-axis at 90 or 270. So it hits the first time at 90. So I'm going to do 110 minus 90 is 20. And that means it has been shifted to the right. So we want that number to be negative, and since in the parent function it's x minus b, our answer is just 20. Thanks. So looking at number 2 on the bottom of the page, this one has the most shifts. So the first one you want to find is your midline. So your midline is the place where it cuts this in half. And normally the midline is at the origin, but the midline is always halfway between your max and your min. And in this case, our max is 6 and our minimum is 3. So halfway between would be 4.5. So that 4.5 becomes our m. That's how much they shifted it up. Everybody okay with that?
Yep.
Nope.
Oh, I said yes. We're good.
And then our amplitude is the distance here. So what's that distance from 4.5 to 6?
2.5? Or wait, no.
Yeah, 1.5.
Yes. Yes.
And then our last one, the B for the period. So our formula, how long it takes it to get from here to, sorry, let me switch colors. Here is 12. And so that's our period. So it would be 12 is equal to 2 pi over b. And then you get that b is equal to 1/6 pi. Okay, next page.
Can you go for 3?
The first number 3 or the last number 3?
Oh, the first number is 3.
Okay, a point moves around the circle. It takes 10 seconds to complete 1 revolution, so I know that my period is 10. And my radius is 5. At the height of the point above the x-axis is given by the function a sine kt, where t is time measured in seconds. Find the values of a and k. So our r is actually our amplitude. So on the unit circle, your r is 1, and that's why normally there isn't a number in front of the function, in front of sine, but in this case, our a would be 5. And then we find our b by taking 10 equals 2 pi over b, or over k, I guess, which is normally our b. And so then you get k is equal to 1/5 pi.
Cool.
Anything else on that page?
I think I'm
So-
done.
For numbers one, the next set 1, 2, and 3 on that page, they give you the formula for a minor arc, that the length of an arc is equal to theta over r. But occasionally, like in question number 2, they ask for the major arc instead of the minor arc. So the minor arc is obviously the smaller one and the major one is the bigger one. So just a reminder that to find the major angle, you just do 2 pi minus the minor angle, which is not a formula on your formula sheet. Which, I mean, makes sense. Like, you're just taking the rest of the circle. So if the whole circle is equal to 2 pi, then you just subtract the small part they gave you. Okay, next page.
Can you go for 8? Is that the one with the triangle?
Yes, the diagram. The diagram alongside shows an equilateral triangle with side lengths r equals 5. So basically what the question is saying, let me draw my triangle first, is that I didn't do a very good job of making my triangle hit the edge of that. But, basically at these points where it intersects are 3 other circles. So if I were, I'm going to do this in a lighter color. This is the center of a circle. I can't with a stylus. I forfeit. I give up. If you start with a triangle, and then there's a circle at each edge of the triangle, basically. I promise I'll get the picture right. So basically these 3 points are what makes the shape of this circle around it. I don't know how else to describe that, but basically these points here, like this is the center of the yellow circle, this is the center of the blue circle, and this is the center of the orange circle. If these were all the same size, then it would make the shape that you're looking for. But unfortunately, I can't do that. But if the radius of your triangle is 5, then this shape that's on the outside edge here, you're just finding the length of that arc in terms of this triangle. Like if this were the center of your circle, then that makes an arc. And then this one makes an arc. This was the smarter way to do this, and this makes an arc. So this one goes with this one, and this one goes with that. Does that make sense? Better? I did better the second time. So the radius, so the distance from, let's say, for all of these triangles, is 5. And the centers are the vertices of the triangle. So basically, we do know what the angle is in these triangles. Do y'all know what it is? If it's an equilateral triangle.
60 degrees.
Yeah. Mm-hmm. So we have 60 degrees is our angle for all of these. And so the perimeter would be, we can find the length of any of these arcs is equal to 5 times 60. and then there's 3 of them. So the perimeter would just be equal to 3L.
And then you would do the same kind of thing for 9.
9 and 10. Yep.
Cool.
Um, ten is air quotes arguably harder. I don't think it actually is that much harder, but just because you can't use your calculator, so you have to be able to do math for number 10, but otherwise it's the same thing. Okay, next page. Which starts with number 11 and then goes to number 3.
I have 11, then it goes to 12, then goes to 1.
Yeah, 11, 12, 1, 2, 3.
Oh, okay.
So number 11, do you guys know how you would do that one?
Do you do like the arc length formula?
You will use part of the arc length formula.
Oh, I got it.
Okay. So the shape, if you were to imagine a sector of a circle, it looks like a pizza slice. And it's asking us for the perimeter. So this formula here that you just told me gives me this length. What would these sides be? What letter? What?
The radius, right?
Yeah, so this is our radius right here. So the perimeter of this circle would be 2R plus L. Right? The 2 yellow sides plus the green side. And then using the length formula, the length of an arc, we have 2R plus theta R, and they gave us theta. So now we have 2R plus 0.4R, which is 2.4R. And then they gave us the perimeter is 12. And then you just solve for R. I feel like there are a lot of questions like this on the IB exam. You'll get lucky and you'll get a few where they just ask you to find the length, but this is more common.
Where does it give the perimeter? Am I just blind?
A sector of a circle has perimeter P equals 12 centimeters.
Okay. Okay, cool. Oh, I thought we were on 1. Okay.
Anything else on that page?
Nope.
All good?
Mm-hmm.
All good.
Next page. Starts with, this one just goes 1 through 7. And this is the last page, I think.
How would you do 3?
Okay. So this one's no calculator. It tells us that it has a radius of 10 centimeters. And then A and B lie on the circumference. So if I was drawing a picture, if A and B lie on the circumference, this is A and this is B of the circle. And then it says that the sine of this angle is theta, radians. Calculate the, and then it gives you the area is 40. So we're going to use the area of a sector formula. So that's just on your formula sheet. And that's 40 equals 1/2 theta 10 squared.
You said that's the area of the sector formula?
Yeah. And that one's on your formula sheet. It's area equals 1/2 theta r squared. And so theta is equal to 0.8.
Cool.
Can you do 7?
Yeah. So 7, what I would do is you can use that area formula to find the area of that entire pizza slice, that area of a sector. So this is area equals 1/2 theta r squared. So in this case, it would be 1/2 theta 6 squared. Did they give me theta?
Yeah.
45. So once you have this, which I have my calculator here, that gives you the area of the entire sector, which is not the shaded region, but rather more than what you need in the shaded region. 0.5 times 45 times 36. So this is equal to 810. And then we can subtract the area of the non-shaded triangle. So this triangle that looks like this with the height of 3, we can figure out, since it's a 45, that means this is 3, this is 3. And this would be square root of 18. Not that you really need that, because since these are two 45, 45, 90 triangles, if you were to take this triangle and turn it here, you just get a square, a 3 by 3 square. So the area of these two triangles is equal to 9. Or sorry, that's the, somebody wake me up, please. You do 1/2 base times height. So you have 1/2 times base times height, which is 4.5. So once you have that, you just do 810 minus 4.5.
So on Wednesday, are we going to go over this packet, or are we
No, this was your chance for this packet. I mean, if you have other questions, you can message me individually. On Wednesday, I'll post on Google Classroom probably sometime tomorrow. We're going to go through a mock of just circle questions. So they're from exams. And then on Friday, the packet that y'all picked up, there were 2 non-calculator mocks and on Friday, we will start vectors.
Okay, so the mocks, I didn't pick those up. When we need them, can you post them?
Yes, I will. So those are actually, so the calendar, I could actually probably pull it up. On, just so everybody gets to see this, I guess. So today we went over circles, and then Wednesday we're gonna do a circle mock exam. And what I think I'm going to do is post it Tuesday, and then I want y'all to just do what you can. And then on Wednesday we'll go over it and talk about it. We can go through all of it, but I just like you guys to see what you know. If you don't get a chance to do it, then that's not a big deal. Like if you have done 0 of it, that's just your loss. It's no skin off my back. And then Friday, we will review vectors the same way we basically just did right now. And then next Monday, I'm hoping that we will be back in school, but we don't know that. But whether we're there or not, you'll do a vector mock the same way we're going to do a circle mock. And then Wednesday, we'll do the paper 1, which is no calculator. And that's for vectors, circles, and statistics. And then Friday will be a paper 2 of the same thing, of vectors, circles, and statistics. Now I'm pretty sure I made 2 of each of them, right? For y'all?
I have no idea.
Yeah, I know you don't. I think I gave you each 2 paper 1s and 2 paper 2s. So that you have one that we can go through as a class, that instead of y'all taking it like it's a test, we'll go through it and I'll say, okay, when I read this problem, this is the first thing I would do. That we can go through, where do we start on this type of problem? What are they asking me to do? And then you can do one for homework that is on your own. Similar structure, but just not the same questions. And then I'll post answer keys, like mark schemes for all of them, just so y'all can also become familiar with how are these being graded.
Cool.
And that'll just be the problem pretty much for the rest of the semester, whether we're in class or not. And then the last week before exams, we'll do, what is it called? Jeopardy.
Nice.
Yeah, so. But what I will do now is I will post this video to YouTube, and y'all can just go ahead and follow me on my channel. But I will also put some of these types of questions on Delta Math. Now you have this obviously too. I have not taken the time to make an answer key for this particular packet because I didn't think I needed to. I'll make it for the mock that we're doing tomorrow, but for this in particular, I was like, this is just a practice. Just do what you can, do what you want. But if there's a certain question that you're really stuck on and you want to make sure you're doing it right, just let me know. Cool. Any questions before we're done?
So this is just practice.
Yes. Nothing else is really, there are things that I'll be air quotes collecting, but nothing else is really for a grade other than me putting grades in the grade book. like effort, completion,
Okay.
I tried this grades. But the practice packets are just for you, not for me.
Cool.
Cool. I'll be sure to make that clear on Google Classroom as I post assignments as well, whether I'm collecting it or not.
Yeah.
Anybody else? Cool. Then have an amazing day, everyone. Don't die of the coronavirus, please.
Thank you.
Bye.
Hi. Hi, Elizabeth.